going to be doing it on HackerRank, and I don't have a ton of time, and this wasn't really scheduled, so I'm just going to do it for, do one problem and call that good. So without further ado, let's go ahead and start it. Okay, so, and actually, sorry, I won't turn off my desktop. I have a gaming machine that I use some mining, crypto mining, because why not? I'm a nerd. And then I run the stream off my laptop. Side note, I am applying some updates J vulnerability out, so hope everything is okay. It looks like stream quality is okay from my end, so we're all right there. Okay, so let's get started. That looks big enough. I think size stayed for me, so manageable. If you're in the chat and you need it to be bigger or smaller, just know. So consider an undirected graph where each edge weighs 6 units. So each hop is going to be identical. Each of the nodes is labeled consecutively from n, given a number of queries. For each query, given a list of edges, describing a graph. After you create a representation of the graph, you must determine and shortest distance to each of the other nodes from a given starting position using breadth first search algorithm. Return an array of distances from the start node number unreachable, return -1 that node. Okay, so the graph is based on this one start. Two. This is the starting. Oh, okay. 6, -1. Reachable graph. BFS function, if unreachable. BFS has the nodes, edges, and okay. Size of the array. Int s. The node to start the pixels. Okay, so S is straight start. So usually build a notation graph. I use a hash map, which there's a bunch of different ways that you can decide to that, but a graph of nodes to a list of nodes that you can reach from there is useful. And then from there, track a visited hash map. We may actually need a visited hash set. So we may actually a visited hash set because since the node is, or the graph is undirected. Okay, so yeah, undirected is fine. It just means that as we're building out our representation, we need to add relationship in both directions from each of the nodes. That shouldn't be too bad. We need to track a visited hash set so we don't visit the same node once. And we need to track a best distance, a shortest distance hash map with destination shortest. And that's so that we can start, this is essentially Dijkstra's algorithm, part of Dijkstra's algorithm. Start with a list of the destinations you're trying to reach with a cost of infinity. And then as you find valid distances, then you can track back to them, update that. And after that, we are going to, I think, stack graph starting point Um, a push to the stack. 5 if a node did check if distance. Which actually, now that I'm saying that, I think I'm actually going to do this recursively because that'll make it a little easier to track the current distance. So recurse through graph that can pass down map of nodes to reachable nodes. And then we just need to pass a visit set. And yeah, I think recursion will be easier. So we'll recurse the graph, passing and parameters. And then if shortest distance is closer, if found a shorter path. And it doesn't say anything about returning actual path there. It's just asking for distance. So that kind of makes this easier because we don't need to keep track of like the list of nodes that we just get to keep track or track the distance. So let's go with a static about this. The more I'm debating recursion, recursion is now I'm really on the fence. So with recursion, we are going to be recursing outward. We also need to pass down. Well, no, I guess we need to pass down a shortest distance map anyways. And okay, so we may not be returning anything, but we'll be using the shortest distance list or array, whatever we choose to go with, represent that. So let's go with recursion, or at least there. Static void BFS helper. And here we're going to have n and add a current per distance. We're going to have a hash set going to get involved. Set did set and then a hash map integer to destination shortest distance. We have to initialize that with large values. Actually, I think this is going to, in the end, is going to represent our result list. It's going to have to grab the values from it in order. Interesting, but we should be fine. We're going to have to iterate anyways to swap infinity for. So I think that should do it. So let's think through our base cases. So base case is if did set dot contains current node. I've already looked at this node, and there's no need to go back and do it. So return. Their base cases. That's it. So we're basically know now that we haven't visited this node yet. So then next we need to check if the current distance is less than the shortest distance found. So say if uh, oh no, yeah, that's right. Current distance is less than nation to shortest. Like I could have made that shorter. Get current node and update nation to distance dot put current distance. So and then the thing we need to think about is that changes paths or shortest paths that we found because there's a chance paths to a node. Let's say there was let's say there was a 5 was connected to 2, and if I visited 3, 5, find a 1 hop, but if I then visited 2, I'm not going to visit 5 again because it's been visited, but I've actually got a shorter path there. So I think that I need to iterate any nodes that are, oh no, and this is, yeah, that's tricky. So when I do this search, or when I do second search 2 to 5, then I do need to update the there. So I'm starting to wonder if the visited option is actually going to work, because there might be those where the node device. I'm missing some stress algorithm. Shouldn't be that high in runtime. Yeah, so actually in this one there's okay, so I think the out there is, in this case, I do need to traverse again. So here I've made a change to my shortest distance, and I need to find out if that's changed any of the other distances that I've got. So I think the visited set is actually not the right way to go. I think the option, or the better option, is to say, if I'm not updating distance, then I'm not going to recurse this child or this node's relationships. But if I have made an update, then I'm going. So let's keep that for now. I think that's not what I thought it would be. It might be a case of feature optimization, which is really risky. So, okay, so here, destination to actually have a, I don't. So hash map to hash manager node to node all this relationships. Okay, and then in this case, I want in relationships get kernode. Then I'm going to recurse into my BSF helper. So BFS helper, I'm going to call next node, take distance 1. It's going to see, we're going to pass in relationships, which isn't going to change. And we're going to pass in, I copy paste that variable name, way too long. Okay. I think that makes sense to me. So at the beginning, if I have found a shorter path, my current node, I'm going to update it and I'm recurse into the relationships because it's possible that I found a better path now. If I don't, then I'm just not going to recurse. And it's going to leave, I'm going to have to see my shortest distance relationships with positive infinity. At the end of this, I'm going to have a map where that's going to be node to positive infinity, and I'm going to iterate it and then transform the actual distance -1 or multiplied by 6. Edges are all at 6. So let's go ahead and do that. That shouldn't really be that bad. So I equals 0, and I think n is the plus, and then hash map destination to distance and hash map. Okay. And then actually, let's just see everything. Well, no. Buys this much, and it makes it a lot harder to logic. So destination to shortest dot, what can I call it? Shortest node to distance. Both node to distance. Goodness gracious, that's too much. Node to distance dot put. I'm gonna go I to positive. Okay, so here we've distances. Now we need to build out the relationships. Hash map integer to hash set relationships is going to hash map hash set list ship jizz. All this for edge and edges. And then we've got to do just a pretty standard relationships dot put if edge at 0 new hash set integer hold that correctly. This has to be dot get 0 1 correct to me. I could make this bigger. Okay. Can't, we'll just fine. Okay, so now we've done our seeding. So at this point, ships.get edge.get add edge ships. So this first part is just setting us up with empty hash maps if we don't have one already. Second step is to populate them with edges. So now at this point, we've got our node to distance, infinity, and we've got our relationships set up. So I think the last thing is caller recursion. So BFS helper start at S, cur distance off is going to be 0. Relationships is not going to change. Change the distance. Easy with same, slightly. Okay. So in theory, this should leave us with a correct distance, and we just need to iterate it, wait back through, and update a new list, the correct. So we're going to do a alt equals new list sure I 0 a n plus. Hi, and it looks like somebody might have joined, so we're hanging out. We're partway through a BFS, shortest edge or shortest problem. Okay, so here we need to get shortest distance node to distance. Then if distance is dot div. In this scenario, or in this case, we know that found something reachable, and the result that they actually want is -1. Add negative there. Else, we're going to add then we know that it's valid. And it's safe to just get from testing that because we seeded this 0 to n already. Should just be able to return node 2. So that's a lot. Go ahead and run it and see what happens. Compilation error. Add. Part if you're ever interviewing where you start to look silly, just or nonsensical. Cannot find the symbol. Spelled incorrectly. Figure out what I'm asking. Integer.max value. Okay. It's not positive infinity. That might be a double something, but max value should get us essentially the result. It is good to keep in mind that with the change or with that, technically, you could have, if you had a really large graph, you might find. distance, and the result with the array list setting up. So let's try that again and just see which errors we get. Find symbol. Up. Silly. Just try that. Error. Not find symbol relationships. 5. And if you're ever interviewing, trying to do a coding challenge, like most grasp that in general you're writing code with an IDE, and it's really not that big of a deal if you're struggling a little bit, but it just distant to distance. Saying that makes sense to me. So let's do some printing. Node. Distance. Relationships. Eyes. Node to distance. Try that. I'm puzzling on how that could be null. They shouldn't be, but hopefully the output will. One current distance. Two. And hop back and forth. Distance.size chain. At 70. What am I saying? guess is it distance isn't try would to distance no, should be fine. So let's try it. Oh, so with this, our null point should jump up a line or stay on the same line, but be on the previous statement. So current node is null. Distance for there. So distance just out. Okay, let's do what we get there. So I would expect to see us everything. Us. I. See if um. So now I'm trying to see if something updating this map is breaking. Which welcome to software engineering. There's always a bug. And since merge, there's time. Okay, so we're be running times see two, and down here I've got 0, 2. Notice, okay. So if n is based in thing consecutively from n, goodness gracious. Okay. So the quick and dirty fix to make sure I'm on the right track is seeding these values, and that is going to lead to having single invalid node, or have one extra node, 0. So I'll have to how to fix that. Yeah. Okay, so now we're getting the wrong answer, but at least we're completing. And we're getting one extra. Okay, so let's slow down and think the right way to. So the as unbased indexing. So either we need to shift all function up level so that we do 1 to n, which and then the alternative would be to add one transform down here, building out our result. So take a look at it. Shift all of the information up. So distance, I for edges, that one would be start would be. This would also need shifted up. Or not ever actually iterating. It's going through the next node. So I think that should actually take a bit. So starting from 1 and going to 10 should solve that problem. Might still have some correct answers, but I think that's a solution. Yep, that's not right yet. Well, the first thing we need to do is multiply 6. Should get a step closer. 6, 6. And I think my issue here is, not sure what my issue there is yet, but I am getting, because I'm making the first node. So I think that's got to be it, where I want to my start node ways to do that. And then I think if I exclude my start node, I'm actually right. A 0 and a 0 from starts. About the right way to that. I don't really want to hack that into the S helper, because it is like, get to yourself, it is a distant 0. And as ugly as it is, I actually so if I'm going to do it when I'm modifying for my result. So I don't love that as hacky, but at the same time, something needs to know that our art and the DFS or the BFS result here is correct, where distance to yourself is 0. I think I like it more than handling that in the results transform, which is a little bit funny anyways because I'm doing it with that. But with that, we are passing. And this is a HackerRank medium, so fantastic. Maximum score is 55. Got a hacker. Okay, time limit exceeded. So there's something inefficient that we're doing, which I'm guessing that I'm not going to get a score. But the logic is correct enough that it's worth it. Let's spend just a minute and see what I can do. Obvious thing. Printing is pretty expensive, and I was at both, and I had a BSF. BSF helped out, and we'll see what that does to our time. I'm gonna go 2D minutes, and I'm already coming up on 40. Still correct, which makes sense. We didn't try pass. Hey, okay, all but one. That one. Oh, 5 runtime error. But unless it was like a Stack Overflow yeah, I'm not gonna take the time to modify this. Um, chance empty. That because I yeah. Try it one more time. Environment really not my fault. Some kind of without being able to see what yes. But I'm gonna call that good. So with that, thanks everybody for hanging out. Ooh, thanks everybody for hanging out. Appreciate you tagging along and scheduled to do this again tomorrow night. So I'll see if we can find some time and we'll crack open another problem. Thanks. Have a good night. Bye.